What if the universe was made up of tiny, vibrating strings instead of point-like particles? What if these strings existed in more than just the 3 dimensions of space we know, but in 10 or even 26 dimensions? Hey there, folks. Welcome to our channel. Here we explore the latest trends and developments in the tech industry, from cutting-edge technology to the latest science discoveries. In this video, we will expound on the string theory. But before we move forward, don't forget to like the video and subscribe to our channel and tap the notification bell so you won't miss any of our uploads. Why string theory? General relativity and quantum mechanics are 2 scientific theories that accurately describe the behavior of the universe at vastly different scales. While general relativity explains the large-scale phenomena of space, time, and gravity, quantum mechanics explains the behaviors of particles on a very small scale. Despite their effectiveness in their respective domains, these theories have been found to contradict each other, creating a major challenge in understanding the fundamental nature of the universe. Albert Einstein was able to unify the concepts of space, time, and gravity, but other forces of nature remained unexplained. The weakness of gravity compared to other forces makes it difficult to detect or observe its effects on a particle scale. Scientists have proposed the existence of a particle called a graviton, which would explain the force of gravity at the particle level. However, when scientists try to predict the behavior of gravitons colliding with one another, they end up with mathematical inconsistencies, indicating that something is missing from our understanding. The effects of gravity can only be observed on the scale of extremely large objects in space, while quantum particles are so small that gravity becomes negligible in their interactions. In an attempt to reconcile these seemingly incompatible theories, string theory was developed. String theory seeks to unify all the fundamental forces of nature, including gravity, into a single framework or theory of everything. However, string theory remains a theoretical construct, and its predictions have yet to be experimentally verified. How string theory works. According to string theory, particles are not point-like objects, but rather tiny one-dimensional strands of energy known as strings. These strings are incredibly small, approximately 10 to the power of minus 33 centimeters in length. Unlike the things we see, which move in 3 dimensions, strings can move in at least 10 different ways and can be either open or closed. Some physicists believe that how these strings move and vibrate determines the properties and attributes of everything in the universe, including particles. To understand how strings can acquire the properties of particles, imagine a guitar. The strings on a guitar are one-dimensional, but when they are plucked, they can vibrate in 3 dimensions, creating a unique sound. What does string theory predict? Physics relies heavily on mathematics to explain and calculate the behavior of the universe. However, there are times when scientists hit a dead end, such as with the challenge of unifying gravity with quantum mechanics. String theory proposes that instead of point-like gravitons, gravity is mediated by tiny one-dimensional strings, which can collide and rebound without resulting in impossible mathematical infinities. String theory predicts the existence of the gravity particle and provides a way to calculate its interactions with other particles, which is essential in understanding quantum gravity. Scientists have also used string theory to explain various phenomena, including the creation of the universe, dark energy, and the behavior of black holes. The theory even proposes the existence of hypothetical particles, such as axions, which could potentially explain dark matter and other particles that have yet to be observed. What does string theory mean? Our current understanding of the universe consists of 3 dimensions of space and 1 dimension of time. However, for string theory to work, we must assume that there are more dimensions present, either 26 or 10, depending on the version of the theory. This raises the question of where these additional dimensions could be, and one possibility is that they are hidden from us due to a process called compactification. This means that the extra dimensions are curled up tightly on themselves, making them undetectable to us. To understand this concept, imagine a power line. To a bee flying above it, the line would appear as a one-dimensional object. But to an ant crawling on top of it, the same line would appear as a 3-dimensional cylinder. According to string theory, something similar could happen to the dimensions in our universe, where the extra dimensions are curled up so tightly that we cannot perceive them. Given this immense range of possibilities, it remains unclear why our universe has the particular particles described by the standard model of particle physics. Some scientists hypothesize that the geometry of our universe may have changed over time, transitioning from one compactification to another, which would alter the laws of physics. Superstring theory. According to superstring theory, particles in the Standard Model have supersymmetric partners, which are yet to be discovered. However, we have previously predicted the existence of electrons, positrons, and other particles before discovering them, so the idea of supersymmetric partners is not completely unfounded. To test this theory, we would need to build a much larger version of the Large Hadron Collider that would create collisions 7 million times more energetic than the current collider. Over the years, there have been many variations and upgrades of string theory, and a unified version called M-theory was proposed in 1995 by physicist Edward Witten. Witten believed that the different variations were all just different manifestations of a single underlying theory, as certain mathematical transformations could be used between these versions. This suggests that all these theories could be different ways of mathematically expressing the same idea. Although M-theory is currently the leading candidate for the theory of everything, much more advanced mathematical tools are needed to fully understand it. So far, string theory remains very speculative and nearly impossible to test experimentally. However, this does not mean that the theory is wrong. As Einstein once said, there was not the slightest indication that nuclear energy would ever be obtainable, as it would require shattering atoms at will. Yet today, we use nuclear power plants on a daily basis. Whether or not string theory will prove to be the correct description of reality remains to be seen, but the pursuit of such an understanding is what drives scientific discovery and progress. So, let us continue to push the limits of our knowledge and understanding, and who knows what we may discover next in the realm of physics and beyond. What do you think about string theory? Do you think it has the potential to be the theory of everything? Or do you believe it's just a mathematical construct that has little to do with reality? Let us know in the comments below. Thanks for watching. Don't forget to like, subscribe, and hit the notification bell to stay up to date with our latest content. We appreciate your support and look forward to seeing you in the next video.